Elena lifts her high school bag straight from the ground to a height of 0.9 meters above the ground. She applies a force of 25 newtons to lift the bag. Ignore the effects of air resistance for 5.1.1. Calculate the work done by the learner. So let's start here by drawing a free-body diagram to see how our forces acting here. So we have so we're going to be having the force. We're going to be having the force applied by the learner. There's going to be the applied force, and then we have obviously gravitational force. We know of no other forces beyond this. And then now it says that the bag is being lifted. That means the bag is going up. Now this is the displacement there. This is the displacement, the direction of motion. So it helps us to determine the direction between the force and the displacement here. So here we have the applied force and the displacement both being up. That means that the angle between them is 0 degrees. And if I have the displacement and the gravitational force now, you see the displacement over there up, and the gravitational force is down, that means the angle between them is 180 there. They are in opposite directions there, the force and the displacement in that case. And then now, 5.1.1 just wants us to calculate the work done by the learner's force. So we have the work done by the force applied will be the force applied multiplied by the displacement multiplied by cos theta. The force applied is 25 multiplied by 0.9, the displacement cos of 0 there. And then we have 25 multiplied by 0.9. Giving us a 22 0.9 cos 0. Well, cos 0 doesn't make a difference, but yeah, very important to always put that there. Is equal to 22.5 joules. The reason why it doesn't make a difference is because cos 0 is 1, so it's like multiplying by 1 there, but it's very important to always put everything there all the time there. So that's 3 marks for that. And we have now 5.1.2. If the mass of the bag is 2 kilograms, determine the net work there. So that means we must now calculate the work done by the gravitational force as well, and then add the two works there. So let's start by finding out what the gravitational force is equal to. Gravitational force is equal to the mass multiplied by g. We have a mass of 2 multiplied by 9.8, giving us a 19.6 newtons there of force there. Then now we say that now the work done by this gravitational force will be equal to the gravitational force multiplied by the displacement multiplied by cos theta, and then we have a 19.6, and then we have the displacement of 0.9 cos of, we said that they are opposite, the gravitational force and the displacement in this case, they are opposite, and we are going to be having here 19.6 multiplied by 0.9 multiplied by cos of 180, and is going to give us negative 17.64 joules there. And now we have the work done by the applied force and the work done by the gravitational force. The net work is now, add them together. The net work is the work done by the applied force plus the work done by the gravitational force. The work done by the applied force, we got 22.5. The work done by the gravitational force is negative 17.64 there. So we have 22.5 positive multiplied by negative is negative 17.64. And then we are going to be having here 22.5 minus our previous answer. 22.5 minus 17.64 actually, giving us a 4.86 joules there network there. So 1 mark for this, and that over there, and that over there as well there. All right, so this would be 1 out of 7. It would be an activity out of 7 there. All right.